Okay, here we go. If the microphone cuts out, I might not notice it. Let me know so that I can stop recording if it's not going to have any volume. All right, here we go. The log properties. There's a few. Product rule. Write this one down. There are like three main ones: product, quotient, and the power function, or the powers rule. So product rule says that if you have something that's a multiply, like this one, 3x, that means that you can break it into two parts. This is a separate problem I'm going to do in a second here. This one can break into log 3 plus log x. Now that is not like normal functions. Normal functions don't do that. I mean, if we had, you know, like 5 times 2 times 7, we could not break that into 5 times 2 plus 5 times 7, could we? This is not normal. This is, logs have all different rules to them, so you got to learn these rules to be able to solve these problems. So you can break a multiply into an add. So if you understood that, here's the same thing, except it's got a base. What was the base on the other one? It was 10. I just wasn't writing it. This one has a base 4. So write down what you think the answer is. Use a pencil or a pen. Need one? Okay. Not a problem. Just let me know and I'll gladly help. All right, here we go. Log base 4 of A plus log base 4 of B. That's all there is to it. You can break up a multiply into an add. Any questions about that? That is called the product rule. So anytime you have a multiply, think about how you could break it into a plus. Moving on. The quotient rule. Quotient means divide. Anytime you have a divide, you can break it into, what do you think? You think it's going to be plus again? That wouldn't make sense. Subtract. You got it. Log 3 minus log 8. Again, that's not what we do with normal math. It doesn't follow the normal rules. All right, so this next one doesn't have a base. Sorry, the first one didn't have a base, so that meant it was base 10. This one has a base. Log base 6 of 4, sorry, minus log base 6 of f. Okay, so anytime you have a divide, you can make it into a subtract. Yep, no problem. All right, there are several little ones that I showed you yesterday. Just want to remind you of a few of them. Do you remember what log base 8 of 8 was? 1 is correct. The way you do it is you look at what exponent is on this right here. And on that 8, there's a 1 for an exponent, and therefore the answer is 1. If I change this to log base 8 of 8 to the third, then the answer would be what? 3. What's log base 8 of 1? 0. The way you can do these if you've forgotten them is you set it equal to x, and then you go 8 to the x equals 1. And if you did that, you might see, oh, x has got to be 0 to make that work. But if you just remember the property that if there's a 1 in the argument, that the answer is 0, that's faster. All right, one more little property. Do you remember this? 7 of log to the power of log base 7 of 10, the answer would be what? 10. If these two numbers are the same, then that one is the answer. All right, I was just doing that little review session because somebody asked if we could leave that up for a second. So, moving on. Power rule. This, another way to break these up, if it's got a cubed on it, or a squared, or any power, you can take that power and move it out front. So this would turn into 3 log 6. Now this is very kind of obscure stuff, and it is very likely your brain will prune this. Some of you won't even leave class today remembering it, but hopefully you can practice it enough over the next few days so that it'll stick. The more you practice it, you can eventually get it to stick long term, but yes?
When's the test?
We are not taking the test today. Today was scheduled to be a test, but we are actually just going to eliminate that test altogether and put it in with the next major test. So basically, you have several days here before we have a test. All right, so this next one is simply 2, but log base e could be written another way. Remember that? What's the shortcut for log base e? ln. 2ln6. See what I just did there? I took the 2, put it out in front. And log base e means ln. There we go. Log base e. ln stands for natural log, I guess you could say. Log natural. Okay, so what do you? How are you gonna? I want to prove to you that this 3 actually would come down and make 3 log 6. Let me see if you can follow this. Do you get that 6 to the 3rd is really 6 times 6 times 6? Do you get that? And you get from the last rule that I just gave you that if you're multiplying something, then you can change it into an add. So this would be log 6 plus log 6 plus log 6. You get that? When you add those all up, do you see that you get 3 log 6? That's why it's okay to take that 3 there, plop it in front. Okay? All right, moving on. Just like this property is unnecessary because there's a property that says if these 2 are the same, the answer is 1. And there's another property that says that if these 2 are the same, then the answer is the exponent. Well, you really don't need both those rules. One of them would have done just fine. If you just said, if these 2 numbers are the same, then the answer is the exponent. The answer is 1. Then you wouldn't even need that other rule. You technically wouldn't even need the power rule that says the 2 can come out front, because how could you change this problem so that you could see that would happen automatically? Just said it to you a second ago. Change the 6 squared to a 6 times 6, and that would change this to a log ln 6 plus ln 6, which would be 2ln 6. So you could just do it that way too. I'm just trying to show you that these properties kind of go with each other. All right, base change. You can't put this into a calculator, but if it was in base 10, you could. Do you remember what to type? Grab your calculator. Do it. If you've forgotten, it's log 9 over log 5. If you guys would work hard to bring your own in the future, I would appreciate that. I do not simply have enough for everybody, so you need to be bringing your own. If you don't own one, talk to your parents about that. That's something you'll need, unless you're a senior, in which case you may want to just borrow one, because in college they might have some other calculator that they would. Most colleges use this one, TI-83s, TI-84s, but all right, log 9 over log 5. You type it in, what do you get? 1 point what? 1.36. Just for kicks, what if a kid thought you were supposed to use the ln button? Let's see what you'd get then. ln 9 over ln 5. Same exact thing, isn't it? It's also 1.36. The point is that when you do a base change, this was a log base 5, and when I type it in the calculator with a base 10 or with an ln, which is a base e, either base e or base 10 gives you the same exact answer. Okay, so in other words, you can have any base there you want. So if a test question said I want you to take this problem and change it, because in Venezuela, their calculators only do base 8. Rewrite it in base 8. It's very simple. Try it. Do you know what base 8 even looks like? You know, there's an 8 in the base, right? So, come on, you can do this. You know it's a log over a log, don't you? And if it's base 8, it's base 8. And then what do you think you put on top and what do you put on the bottom? A 9 and a 5. There we go. See, if it's base 8 or base 10 or base E, it doesn't matter. They'll all be the same answer. Another weird thing about logs. Log 9 divide by log 5.
So how do you put the base 8 in?
You couldn't type a base 8 in because your calculator can't handle base 8. But what I said was, if you were in a different country where their calculators only used base 8, what would you type? You would put in log 9 over log 5 again, because this base does not matter. It can be anything. It could be E, it could be 10. So if they were to ask you, change this to base 8, this would be the answer. That has been changed to base 8.
Why wouldn't that be like log 8 over log 9?
It is. But let's talk about it in terms of base 10, because you'll understand that more. Do you get that this could be base 10? It could be base E, it could be base anything, but I'm going to use base 10 now. Now, what you're saying is that this could be broken in again as log 9 over log 10, right? You know what log 10 is? Log 10 is equal to 1. So when you say that this could really be log 5 over log 10, you're right. But log 10 is really 1. Why? Log 10 is equal to 1 because what you said, which was what? The base is really 10. So what's log 10? It's log base 10 of 10, which the answer is what? 1. See? So this equals 1. So that's why it's okay if I say those are 1s, then yeah, it's the same thing as log 9 over log 5. So I could keep dividing it up like that, you're right, but that's because this is really equal to 1. Okay. Moving on. The main thing is, if you see this on a test, what base is it in right now?
7.
Base 7. Could you rewrite it as base E? Yes, you could. And you'd say log base E and over log base E of 10 over 7. And actually no, that's not equal to 1 anymore because now it's a base E. Okay. So what's that the same as? ln 10 over ln 7. That and that are the same exact thing. When you divide them, you get the same exact answer. Okay, moving on. Just like you could add something to both sides, and you can subtract something from both sides, and you can multiply by something on both sides, you can take the log of both sides. Now this is something I don't want to spend a ton of time on because I did last hour and I don't think they really got that much out of it. You can trust me on this one. If you want to take the log of this side and you move this 9 over here and take the log of that side, if you actually take the time to figure out what log 2 is and what log 9 is, and you can get the answer for this, log 2 plus log x. Why did I just do that? Because that's the rule you just learned. That when you multiply these, it's the same as splitting them up into a plus. Remember that? And you figure out what this is, and you figure out what that is, and you can figure out what x ends up being. So bottom line is, it doesn't very handy in a lot of cases, but sometimes it's really handy. Can I take the log of both sides? Sure you can. Log of this side, log of that side, and it'll work. It'll be okay. Okay, moving on. Here is all the properties summed up in one slide. Now, if there's any of these that you don't know, you might want to write them down, but you probably already have written some of these down, like this one here. XY could be broken up into log of x plus log of y. That's the one where it was a multiply problem, and it changed into a plus, right? This one, it was a divide. We changed it to a subtract. You get that? This one, it's just saying that if there's an exponent here, you can bring it down to the front and say m times log base a of x. That's the power rule. Those are the first three I just went over today. They had base a here. They changed it to base 10. They did a base change. Okay, so that's the base change one. This one's the one we talked about before. If these two are the same, then the answer is whatever the exponent is, which is a 1. If there's ever a 1 right here, the answer is 0. And if there's ever a 0 right here, this is a new one, by the way, then there's no answer. Now that makes sense if you think about it. Log base a of 0 equals x. I always can say equals x and then figure it out. That to the that equals that. A to the x equals 0. How can I take something, put it to a power, and have it end up equaling 0? You can't. And you might think you should put it to a 0 power, but then the answer would be 1. So that's not right. There is no way. So the point is, if there's ever a 0 right here, there is no answer to your log question. All right, and the last one, if this and this are the same, then that one's your answer. The answer's x. All right, so let's do a few rapid fire, simple property ones that should be, really quick and easy if you understand them. Any of these that need explanation? I'll be willing to explain any of them again. Yes? Yep. The question was, in the second one, does it matter which one comes first? Yes, the top one is first. Whatever was on top is first, and then you subtract whatever's on the bottom. Okay? That's a good point. Any other questions about these? All right, so I'll give you some easy ones. Could I rewrite that 25 as 5 squared? And if I did, it would tell me what the answer was, wouldn't it? What's the answer? 2. All right. But wait a minute. Didn't I say that I could take a power like that and put it out in front and say 2 log base 5 of 5? Yeah. Isn't that the same as if I change this 5 squared into 5 times 5 and then write it as log base 5 of 5 plus log base 5 of 5? Wouldn't that be also true? And what's this equal to? 1. And what's this equal to? And 1 plus 1 is? So the answer is 2. There's like 6 ways to get the answer of 2 here. Okay, but the answer is 2. Okay, how about this one? Log base 9 of 3. What if I could write that 3 as a 9 to the something? 9 to the 1/2, that's right. This would be the exact same thing. And why is it better? Because now I know the answer. What's the answer? 1/2. Okay. If you can make these guys the same, then you can find the answer super easy. Okay, how about this one? Log of 5 times n. Log 5 plus log n. Good. What base was that, by the way? All right, it's base 10. What if Log of 5 to the third. Give me something that's the same as. 3 log 5. Yep. Or log 5 plus log 5 plus log 5. All right. How about this one? No answer. How about this one? What's the answer now? Answer is 0. What if you couldn't remember what it was? You were like, I know it's some property, but I need to figure it out. You'd set it equal to what? And then you'd write 28 to the x equals, and then you'd go, what can I put it to the power of? Oh yeah, I could put it to the 0 power. X must be 0, and it would be 0. Okay. Here is your first of the homework type questions for today. Well, it's got two parts. It's got the power rule and it's got the product rule at the same time. The question is, should I pull the 2 out first and put it in front, or should I split it, the x and y first? Split the x and y first, you're right. So this one would be log x plus log y squared, and then you could fix the squared by putting it where? Right in front. You get that? Now what did we just do? We took something that looked really simple and we expanded it out. That's why this is called expanding. So on the test that we have on this stuff, which isn't going to get rejected or whatever you want to call it, skipped, this is expansion. They get to be pretty intense. This is, of course, your first one, so it's pretty easy. But you see, we start with something simple, and then we expand it out into something bigger. And the opposite of that is called compressing. So if you start with this here, and you want to compress it down, you'd say, okay, well, it's an add, so I know I can make it into a multiply. 2 log y times log x. And the y and the x have to get multiplied, so, okay, let's see here. And then I just got to put that 2, oh, wait a minute, now I don't know where to put the 2. So the order that you do these are important. The 2 only is supposed to go on the y, so you'd have to be careful. We're not going to mess with that till tomorrow, but let's do some more expanding. That's the easier kind. Yes, sir? Yep, it does. It does. So the order matters. You'd have to put, so you should have put the 2 back first. All right, so this one. To expand this out, do you get I'd have log 8? Do you get I'd have a log x? And then I have a log y to the 4th, and then I got to fix the 4th power thing by just moving it down to the front of that. That's an easy one. This one's a little more weird. Write it down. Somebody smart's going to figure out something smart to do. Does anybody remember another way to do square root? Do that. If you make that into a parentheses and a 1/2 power, then I've got just the power rule. Then I can slap the 1/2 down in front. Now, I know some of you got the gut feeling that we should do that times that, and that times that. Just like distributive, like you always have been able to do. You can't. Doesn't work anymore. So we can't do that. So we're done. Leave it just this way. Why can't you do that? Let me prove it to you. Would you agree that ln of 1 plus 1 seems like it should be the same thing as ln 2? Okay. Or let's do one that we would be able to do even better. Do you agree that log of 10 plus 10 seems like you should be able to do log 10 and do log 10 again and just add them together? But what is log 10? proving this is not true. Okay. What's log 10? Well, it's like there's a little base 10 there, right? So then what's the answer? 1 plus 1 should be 2. Try doing log of 20 once. What is log of 20? Log of 20 is 1.3, but log of 10 plus log of 10 is 2. 1.3 is not the same thing as 2, is it? So you're not allowed to do that. It doesn't work. You can't do the distributive property on these things. Okay? All right, so back to this one. We were done right here. We cannot distribute that puppy out because that doesn't work anymore in log land. All right. I'd like to skip ahead. Let's do condensing, just baby condensing, really easy condensing. Do you remember how if I put these back, I won't know where to put the 2, whether I should put it on the y or whether I should put it on the x or whether I should put it on both of them. But you can tell by looking at it right away if I just ask you right now, where should that 2 go, on the x or the y? The y. Do that first. Now I can put these guys together, and it's a subtract problem. So that means it should be a multiply or divide? Divide. So it's ln x divided by ln y squared. But there really shouldn't be 2 ln's there. Final answer? ln of x over y squared. Now look at the original. And this is the answer to it. Do you get that? All right. Get the feeling I've come to the end of your brain. So I'm going to jump to the stuff I got to make sure you understand. This is in base 1/2. Is that okay? Yes. It just can't be base 0. It can't be negative bases, but it can be base 1/2. Do you get that this would be the same as log 2 over log of 1/2?
Log 1/2 over log 2.
Nope. This number goes on top. Then, do you get that the bottom, I'll do it in blue, could then be split up? It's a divide. It's a log of 1 over 2 is the same as log 1 minus log 2. You get that? All right. So I just did a big expansion, and at the same time, wait a minute, look at that. It was base 1/2. What base is it now? They don't have any bases, so that means the base is really what? 10. But remember, on base changes, you can make base anything you want to. So if right now they said, we want you to change this from base 1/2 to base E, I could just make it any base I want. E. Fine. It's all base E. There. Or if I'd rather have base 17, 17. Can be any base you want. Usually we choose 10 because the calculator can do it then. But if the book asks you to change base 1/2 here into base 17, you just do your base change thing. One more like that. Log a 6 and an 8 here. Do you get I could do log 6 over log 8 over log 6? What if they wanted it to go from base 6, which it is right now, to base 22? And then it'd be log 8 over log 6, and I can make the base anything I want. 22 is fine. There we go. I just did a base change. Now it's in base 22. All right. This is a funky base change because they ask you and say the answer can only be an ln, or natural log. All that means is log base E, right? We just got done saying we could have any base we want. Log 5 over log 6. And how do I make it be a base E? Put an E. And now I can change them both to what? ln 5 We're ln 6. That's the answer. And now we're getting to the part where we don't need it. Tomorrow we'll go a little bit farther with this stuff. All right, you just processed a lot of stuff. And the homework for today is, I cut it down because we were supposed to have a homework quiz, but none was ever sent out. So I'm not doing that. I'm giving you a little worksheet that could have been the homework quiz, but it wasn't. So I'm giving you this little worksheet plus just the evens. 317, 2 to 22 even. And judging by the amount of time left in class, I think you'd be fine if you could just get this worksheet part done. So I'm going to hand that out right now. And the front page, looks like there's 4 big questions. It's matching. It's like 1 is either A, B, C, or D. And 2 is either A, B, C, or D. And it's really simple on the front page. So let's do this little review together. The very first question says f of x is 3 to the x. Yep. Okay. All right. Generally, don't even look at the choices right now. Do you remember what this one looks like? Is this exponential growth, or is this exponential decay, or is this that logistic function, or is this the natural log? All right, here's some of the things I just said. Here's exponential growth, the black one. Here's exponential decay, the blue one. Here is natural log, the green one. Which one is it, the black, the blue, or the green? It's the black one. Look on your choices, A, B, C, or D. Which one is it? D. So one's D. Number 2 is just like it, except it's got a negative here, which makes it flip. Which way? Up, down, flip, left, right, flip. Up, down, flip. And then the minus 2 here makes it move 2 to the right. So either flip it and move 2 to the right, or move it 2 to the right and then flip it. And then you'll know that it's either A, B, C, or A or B or C, because we already chose D. So problem number 2 is either A, B, or C. Get the idea? All right. Then number 3 is just a log. If you know what the log graphs generally look like, which is generally like the green ones there, then you can figure out which one that is. All right, so it really comes down to your basic knowledge of graphing. And the next page here is you're sketching these graphs, and generally you would sketch 3 to the x minus 2, for instance. If I was going to graph that, I'm fine with you being kind of generic about how the graph looks. Like, I know it has to go through this point right there to start with, right? And it generally is going up. I'm not going to care exactly how steep you make this thing. Okay? If I wanted to know, I could put in points like x and y. Make a little xy chart. Say if I put in x is 2, then y would be 1. Because anything to the 0 power would be 1. So I know over 2 and up 1 is a dot on here. Anyway, so if you wanted to graph this puppy, though, I got to take it and move it 2 spots to the right. So I take this and I move it over 2 spots to the right. And so it looks something like that, which it looks a lot like the original. That and that are pretty darn close to each other. So there's your sketch for number 5. Again, you do not have to make these perfect. Oh, I'm sorry. I thought the minus 2 was in the exponent. Sorry. If it's minus 2 down here, and it moves down 2, so if the minus 2 is like this, then I got to grab this whole thing and move him down 2. Doink, doink. There we go. It's good enough. Doesn't have to be perfect. And if this is good enough for the parent, and this is good enough for the actual answer. That dot's not there. Okay, so anyway, these are sketches. They don't have to be beautiful. All right, so once you're done with that worksheet, again, your assignment's out of the book. This is part of your assignment too. The assignment out of the book is page 317, 2 through 22 evens. We had a long day today, but that means tomorrow will be on the easier side. So, any other questions? Yes, sir.
For the number 4,
Okay, read me number 4.
f of x equals negative log base 3 parentheses x minus 2.
All right. Do you agree that this is basically this graph, except moved? Do you remember what that kind of looks like? Whether it's log base E, which is 2.7, but this is log base 3, which is pretty much the same thing. It kind of looks like this. That's what the log graphs look like. Remember, like a log that's got roots and has been blown over? Okay, so there's your log.
Where's the s?
Okay, the asymptote on that kind is like this. Can never go past 0. Yes. So now if I take the whole thing and I move it 2 to the right, move it over, doink, doink, 2 spots to the right, then my asymptote line needs to move over 2 spots to the right too. I hate to move each of these little dotted lines. There. And then the whole thing needs to get flipped, up, down. Well, the asymptote's not going to have to worry about flipping that, but the other thing has to get flipped, so it's going to look kind of like that. Okay? So learn how I did that one for you. Yes, ma'am.
What do you need number 7?
I'll at least get you started. Go ahead.
Says log is 3, 6 minus 9.
All right. So to me, I should be... Wait a minute. Let me make sure I've copied that down correctly. 6 minus x is in parentheses. That makes a difference. All right, so now, would you like it better if the problem was written like this? So write like that. And now you'll be able to say, oh, it's just a regular log graph that's been shifted 6 to the left, and that inside negative thing is a flip. But just do it in the right order. I know you might not think of that, but the right order for this is normally you do this first, the multiply, so you don't. You do that first. So make sure you go 6 to the left first, and then you flip it. Because if you flip it first and then move 6 to the left, it'll be different. So start by moving it 6 to the left. So if the normal graph for log kind of looks like this, you start by moving that whole thing 6 to the left, and then you flip it up, down. All right. Oh, I'm sorry. It's not an up-down flip. It's a left-right flip. Thank you. The negative on the inside is the left-right. All right. That's enough for today.